Sometimes people consider load charts to be a little old-fashioned. They're very necessary for us, even if you have a crane that has a load moment indicator or a rated capacity limiter, because if you're in a situation where you have a malfunction of your LMI system or you have a problem with the rated capacity limiter, you can go back to your load chart if you're in the middle of a job until such time as you get the system repaired. Also, a great number of older cranes are not equipped with a rated capacity limiter or any sort of an electronic scale, so there has to be some sort of a graphic way to calculate what the capacity of the crane is at any specific load radius. First of all, we want to talk about load radius. There's two things here up on the board that we have. The first one is the graphic representation of what the crane looks like with the boom at different lengths and at different angles. And over here is the chart that is used to interpret the graphic representation so that we can calculate the load capacity of the crane. Now, these particular charts that we have on the board here today are from a Broderson IC83F. Now, each individual crane that we deal with is going to have its own load chart. So we're not intending here to give you a one-size-fits-all load chart. What we're trying to do is just explain the ways in which we use load charts and how they are calculated. Now, the first thing we want to understand is where is the center line of the crane, because the capacity of the crane is determined by the difference between the center line of the crane and the weight or the load hanging on the end of the boom. Now, in this particular case, as you can see, the boom pivot is back behind the center line. Some cranes calculate their center line from the boom pivot pin. On this particular crane, it does not. If you look here, you'll see the center line is somewhere forward of the boom pivot pin, which on this particular crane happens to be the exact center line of the turret where the boom rotates. And so we can use the load chart to calculate our load radius. Once again, the load radius is the distance between the center line of the crane and wherever your hook happens to be hanging at that particular moment. Now, this particular crane, this Broderson crane, has a 3-section main boom with an available and optional 10-foot pin-on jib. And you will see that there are a series of arcs on this graphic representation that show where the boom would move at a particular length as you raise it from 70 degrees and lower it down to 0 degrees. Now, this first arc right here represents the main boom only, with the boom completely collapsed with it drawn all the way together. And you'll see here that from the center line to the end of the boom, when the boom is at 0 degrees, when it's exactly horizontal, is about 11.5 feet. Your next line, your next graphic representation here, your next arc, is with the main boom with one section fully extended. It can be either section, either the middle section or the end section. But this gives you the arc that the boom would move through. And as you can see here also, if the boom was at 0 degrees at horizontal, you would be about 21 feet from the center line of the crane. Now, this is not to be confused with the distance between the front bumper of the crane and the load that is hanging. It is, once again, from the center line. So some of your distance, some of your radius is used up from the center line of the crane to wherever the end of the deck of the crane ends. Your third arc that comes here is with the main boom extended all the way with both telescopic sections moved out to the end. And then this final fourth arc is with the jib fitted in place. Now, you'll notice here on this particular picture on the end of it here, the jib is either straight or it is what's called luffed, or it's offset at either it's at 0 degrees here, it's 10 degrees, or 15 degrees. And so some cranes are equipped with a luffable jib or with an offsettable jib. Some cranes are not. Most of them, the jibs are fixed and they're held in the 0 degree position. So the first thing that we have to do to be able to calculate the capacity of this crane is we have to know what the load radius is. So, for example, if I had my main boom extended all the way out to its full extension, and I did not have the jib fitted at this time, and I had the boom at the way it is right now at a 30-degree angle, I would calculate and run my finger straight down to the number at the bottom, and I would be at a 26-foot radius. You can see the 26 feet right here. For example, if I had the boom up here at a 45-degree angle, if I moved my finger straight down, I would be at about a 20-foot, 5-inch radius or so. It's just a little bit over 20 feet. If I was to raise the boom all the way to the 70-degree position, and I followed this particular point where the arc intersects 70 degrees, bring it straight down, I would be at about a 9-foot radius. And so the shorter the radius, the higher the capacity of the crane. And so once I have used the load chart to calculate what exactly my load radius is, at that point I can go to the chart and I can determine what my crane capacity is at the particular radius in which I have configured it. Now, on this particular chart, there's a couple of things that we have to understand. The crane is rated in two basic ways. It's rated at a 360-degree rotation, and that is the capacity of the crane, and you can rotate the boom all the way around with that particular load without any concern for overloading the crane. Now, in another instance, you can rate the crane as over the front. Now, over the front is generally considered to be with the boom exactly straight ahead at 0 degrees or within 5 degrees of that, which is a very, very short distance. So if you're going to rate the crane over the front, you have to make sure that your boom stays in that over the front position, because as you rotate the boom, you can overload it. For example, excuse me, here on rubber at a 5-foot radius, you have a 9,400-pound capacity rotating the boom 360 degrees. If you have it on rubber just over the front, your capacity is 11,400 pounds. So as you can see here, there's about a 20-25% difference between the capacities that are rated. So we have to determine which we're going to rate our crane for at 360 degrees rotation or over the front. And so it is my preference that whenever you're setting up a lift, that unless it is absolutely necessary, that you calculate your load radius, you calculate your load rating on your 360 degree rotation. That way you don't make a mistake and suddenly rotate the boom and overload the crane. The other thing is we're going to be rated in each of these categories either on rubber or on outriggers. As you can imagine, the crane is much more stable when the outriggers are placed on the ground than it is when it's sitting on its wheels or its tires. And so whenever possible, in any sort of a lifting operation, unless you're going to pick and carry the load, where you actually pick the load and hold it on the end of the boom and actually drive the crane, it's always preferable to rate the crane on outriggers if you possibly can, to make sure the outriggers are down and they're on a stable surface. Now, the other thing that we have to understand is that once we've determined that we're going to rate the crane at a 360 degree rotation, and we've decided, for example, that we're going to have the crane on its outriggers, which is its most stable position, there's also a dark black line on each one of these charts. This dark black line indicates the difference between the crane's tipping point and where the crane is going to be structurally damaged. For example, when you are on outriggers, if you are at a 16-foot radius, you're above the black line. That means that if you overload the crane is not going to tip over. The crane is going to be structurally damaged if you overload it. This represents the crane's structural capacity. When you go below the black line, that is limited by the tipping capacity. When you're on outriggers, when you're at capacity, you're at 85% of tipping capacity. So anything that is below the black line, if you overload the crane, you're going to tip it over. Anything that is above the black line, if you overload the crane, you're going to damage the crane itself, bend the boom, so on and so forth. And so, in the example that we gave over here, as you come down with the boom extended all the way out at 30 degrees, you come down here and you find that you're at a 26-foot radius. In other words, you're 26 feet from where the hook is hanging to the center of the turret. And so, if we come to our chart here and we go to 26 feet, if the crane is on rubber, my capacity is 650 pounds. If you come to the next chart, which is on outriggers at 26 feet, my capacity is 2,050 pounds. Now you can see that this being a 17,000 pound maximum capacity crane, that as you move away from the center line, your capacity drops very, very quickly as you move away from the center line. And so the other consideration that we need to have is how many parts of line are we using. For example, on this particular crane, if you look down here, it says use a single part load line for loads up to 9,000 pounds. So if your load is 9,000 pounds or less, you can use a single part line. But if your load is going to be more than 9,000 pounds, but up to 17,000 pounds, you have to use a two-part line to make sure that you have the winch capacity, because the winch is hydraulically limited, that it will not pull more than 9,000 pounds on a single line pull. And so once you've calculated that radius, 26 feet, if you only had one boom section out instead of two extended, you would be at 21 feet. And here, if you look here, if I'm at 21 feet, there is no 21-foot space upon the load chart. You have 20 and 22. So whenever your radius falls in between two spaces on the load chart, you always go to the next higher ones. For a 21-foot radius, I would use a 22-foot rating. And so on rubber, I would have a capacity of 850 pounds, and on outriggers, I would have a capacity of 2,650 pounds. And so when you have the jib fitted, if you go down here to the bottom, this bottom load chart has to do with the 10-foot jib extension. Now, the jib extension is there for lifting very light loads to very high heights at your maximum height that the crane will reach. And so you have to make sure that if you're using the jib, that you use the jib chart that's on the bottom. Now, here we have the boom extension angle, which is either 0, 15, or 30 degrees. And so if it's at 0 degrees, you use the 0 degree chart. If it's at 15 degrees, you use the 15 degree chart. And if it's at 30 degrees, you use the 30 degree chart. And so in this particular case, most of the cranes that we sell have a non-offsetable jib. And that jib is at 0 degrees. So if I'm using the jib here, I would use the 0 degree boom extension angle. If the boom of the crane is at 0 degrees, this is the angle of the boom of the crane, I have a 2,250 pound capacity. When the boom of the crane's at 30 degrees, this angle here, that you see here at 30 degrees, I have a 2,600 pound capacity. When the boom of the crane is at 45, I have a 3,200 pound capacity, and all the way to the point where your boom is almost standing straight up at 70 degrees, I have a maximum of 7,000 pound capacity. Now this chart right here just gives you the capacity of the jib itself. Once the jib is fitted, for example, if I had the jib fitted at 30 degrees, I would go here, it's non-offsetable, the jib is at 0 degrees, the boom is at 30 degrees, so my maximum jib capacity is 2,600 pounds. But I would also go over here and I would check my radius, 34 feet. If I go to 34 feet and I come across here on outriggers, the capacity of the crane itself is only 1,400. Now, the jib will hold 2,600, but the crane will hold 1,400. You, of course, always use the lower number. So, 1,400 pounds, if you look here at a 34-foot radius on outriggers. Now, one note here, these cranes are equipped to pick and carry. In other words, picking up a load and driving very slowly, a maximum of about 2 miles an hour across even ground. But you never use the jib to pick and carry. Whenever you are picking and carrying, you have to use it on the main boom. You never use the jib to pick and carry. So that's just a basic overview of how a load chart is used. Remember once again that when you're above the black line, we're limited by structural capacity. When you're below the black line, you're limited by tipping capacity. And so you don't want to invade that safety factor that you have of 15%. So never overload the crane, and you'll always have success in your lifting operations. Thank you for your attention.